All right, in the last section we looked at integer exponents. In this section we're going to look at rational exponents. These are exponents that are rational numbers or fractions. A to the 1 over n power, if n is an integer, a to the 1 over n power gives you the nth root of a, and more generally, a to the m over n power results in the following. The denominator of the exponent tells you what root you're taking, and the numerator of the exponent tells you then what power you're raising that to. And it doesn't matter if you take the root first and then raise it to that mth power, as we're doing here on the right, or if you raise a to the m power first and then take the nth root. One of those could end up being easier to compute if you're working with like numerical expressions. And for example, in this first example here, 27 to the 2/3 power. Now I could write that as 27 squared and then take the cube root, but I'm going to find it more convenient to think of this as the cube root of 27 all squared, and that's because I know the cube root of 27. 27 is a convenient number here. The cube root of 27 is 3, so this is 3 squared, or 9. Similarly, down here, 9 to the negative 3/2. So the first thing I'm going to do here is deal with that negative exponent. So this is 1 divided by 9 to the 3/2, and now I'll deal with that rational exponent. I'm going to take the square root of 9 and then cube it. That's what that exponent tells me to do. I know the square root of 9 is 3. So this is 1 over 27. Okay. Next, here we have an expression with some variables in it. We're going to simplify. Now, all those rules of exponents that we learned from the last section and that we learned in the last semester, they're still valid even when we're working with rational exponents. So I've got some negative exponents, I've got some integer exponents, and I'm raising all to the 4/3 power rational exponent. So there's more than one correct sequence of steps you could take. I'm going to choose to kind of deal with this negative exponent first. So I'm going to rewrite the stuff in the parentheses as a fraction. So on top I have 8c squared. On the bottom I have b to the 4th. And this is all raised to the 4/3 power. Now I've got a fraction that I'm raising to a power. So I know I can distribute this power over division. And when I raise the top to that power, I have a product that I'm raising to the 4/3 power. So really, in effect, I could take this 4/3 power and apply it to all three of these factors that appear in the top and the bottom. So I've got 8 to the 4/3 power times c squared to the 4/3 power divided by b to the 4th to the 4/3 power. The numerical part, 8 to the 4/3 power, I'm going to simplify that by applying the definition of a rational exponent. This is going to be the cube root of 8 raised to the 4th power. Now this next piece here, and this piece, I'm going to use that property that says when I take an exponential expression and I raise it to a power, I can multiply the exponent. So 2 times 4/3 is 8/3. This is c to the 8/3 power. And on the bottom, 4 times 4/3 is 16/3. That's b to the 16/3 power. And now all that's left to do is to simplify the numerical expression here. Now the cube root of 8 is 2, and 2 to the 4th is 16. Alright, let's do another one. I've got negative exponents here. I've got b to the negative 1/5 inside, and then I'm raising the whole thing to the negative 1/2 power. So I'm going to start by trying to simplify what's inside the parentheses. And I'm going to begin by putting that b to the negative 1/5. I'm going to move that in the bottom to the positive 1/5. So I've got 4a to the 5/6 over a to the 2/3 b squared b to the positive 1/5. This is all raised to the negative 1/2 power. Alright, now I can do some more simplifying in the parentheses. For starters, here I'm dividing, or I've got the same base and I'm dividing, so I can subtract those exponents. So 5/6 minus 2/3, get a common denominator here. So this is 5 minus 4 over 6, which is 1/6. So that's a positive 1/6, which means I've got a to the 1/6 up top. In the bottom, I've got a product, so I can add those exponents. 2 plus 1/5, that's 2 over 1 plus 1/5. We'll get a common denominator. And that is going to be, what, 10 plus 1, or 11/5. So that's b to the 11/5. This is all raised to the negative 1/2 power. Okay, now, one effect that you can have if you're raising a fraction to a negative power, I'm going to show you this up here a little bit, a note in the margin. So let's say I have a over b to the negative n power. This is the same as, I'm going to go through it a few steps here and then make an observation. So I've got a to the negative n over b to the negative n, because we can distribute. And then I can switch these around to make the exponents positive, b to the n over a to the n. But look, I can also take this and rewrite it as b over a to the positive n, and that's what I want you to observe here, that this a over b to the negative n is equal to b to the a over n. So you can, when you have a fraction raised to a negative power, you could flip the fraction over and make that power positive, and that's what I'm going to do down here. So I got b to the 11/5 over 4a to the 1/6, all to the positive 1/2 power. And now I'm going to distribute that exponent. Okay, so let's see. Raising a power to a power means I can multiply 11/5 times 1/2 is 11/10. On the bottom, 4 to the 1/2, that's the square root of 4, so that's 2. And 1/6 times 1/2 is 1/12, so we have a to the 1/12. And that is our final result. Alright, one more. We're going to simplify this expression, and before we start, I'm just going to make a note that we got to slow ourselves down a little bit. Here we are subtracting some expressions, so I always make sure I'm a little bit extra careful when I see addition or subtraction. I'm going to first deal with the negative exponents that I've got. So in the first part, the 4x to the 4th to the negative 1/2, it's the 4x to the 4th, all of that, that's the negative 1/2, so I'm going to throw that whole thing in the bottom and change that to a positive 1/2 power. Now for the second one, it's just x that's raised to the negative 3rd power. So the 3 stays up top. So that fraction, 3 over x cubed, that by itself is already simplified. I'm going to simplify this first fraction. I'm going to distribute that 1/2 power. Four to the 1/2, as we saw in the last example, that's the square root of 4, or 2. And then we can multiply these exponents. 4 times 1/2 is 2, so that's 2x squared. So now I've got a subtraction of fractions. So to finish simplifying, we're going to do the subtraction. The common denominator will be a 2x cubed. So this first fraction needs to pick up a factor of x. The second fraction needs to pick up a 2. And our common denominator, 2x cubed. Up top, we've got x minus 6.